Hey everybody, Mrs. Bianchi here. We're looking at question 1. Choose the equation that is modeled below, and they give us this. So what do we notice? We notice we have 2 bags, and then we have 4 of these cubes. So we have to look and see which answer choices might offer something that fits that. So which one do we have here? So I see 2x several times here in the lineup, but what are we adding to the 2x? So if we say that a bag is x, and we have 2 of those, that's consistent with being equal to 2x. And what do we have here? Well, we have 4. That's on that side of the equation. Now over here we need to count how many are there, how many of these little cubes are here. So if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Choose the equation that matches that. For number 2, it's saying which equality property is being modeled. And what they're doing here is they're taking this off. That's being eliminated. So this is being eliminated. So if we're removing it, which property is that? If we're taking it away, you should know which one that is. Let's look at question 3. Now question 3, if we look at what we have left, we have 2x equaling 1, 2, 3, 4, 5, 6. So which one matches that? When we look at number 4, they're asking us to solve. This is the same thing that we were just looking at for number 3, only now we have to solve. So if we're solving 2x equals 6, on your piece of paper, what do you need to show? You need to show that the opposite of multiplying a variable by 2 is to divide it by 2. If we simplify this by dividing by 2, we get 1. 1 times x is x. So the only thing left you have to do is do 6 divided by 2. Now another way to think of this is to realize how many must be in each bag. This one would be in this bag, and this group would be in this bag. Let's look at number 5. Choose the equation that is modeled below. Again, we have one bag, which we're using x, and then we have 2 of the cubes. Over here, if we count, we have 1, 2, 3, 4, 5, 6, 7. Choose the equation that matches what I have written here. Keep in mind that we can use commutative property. In other words, if we switch the order of the addends, it does not affect the sum. Number 6 is asking us to solve. It's the same question, so it's a good idea to write this equation down for number 6. X plus 2 equals 7. The opposite of add 2 is to subtract 2. So if we take those away and we take these 2 away, on paper it would look like this. This cancels out. Bring down the x and count up what we have left. Count up how many blocks we have here, or just simply do 7 minus 2. For number 7, it says choose the equation that is modeled below. So let's count how many cubes we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 cubes on this side. Now we have an unknown here. We don't know if this is equal. And then over here we have 3 of the x's, and we're adding to that 2 of the cubes. So which one matches that? Which equation matches that? Because for now we have to assume that they're equal. For number 8, now they want us to solve. So this is the same exact thing we were just looking at. 14 equals 3x plus 2. Let's write it again. 14 equals 3x plus 2. What's the opposite of add 2? It would be to subtract 2. We'll do that from both sides, and let's model that so we can see what that would look like. So if we take these 2 away, that means this is gone and this is gone. So what are we left with? Well, we have 3 of these, which we're calling 3x. And over here, if we just subtract 2 from 14, we're left with 12 cubes. All right, so now we have to decide how many of these cubes are in each bag. So we're doing equal groups of 3. Now on paper, the inverse operation would be to divide by 3 on both sides of the equation. If we simplify that, we get 1. 1 times x is x. And what's 12 divided by 3? That'll be your answer. But let's look at our groups. So if we do our 3 different groups, we would have group number 1, group number 2, and group number 3. So group number 1 would go in the first bag, group number 2 would go in the second bag, and group number 3 would go in that third bag. So how many are in each group? And that's going to be your answer for number 8. Let's look at number 9. Now this one, if you look carefully, we have some inequality symbols. We have the not equal sign. So let's first look at what's in the image and decide why we're using the not equal sign. Choose the inequality that is modeled below. For your information, this example has no solution. It will make more sense why after you answer question number 10. So here we have 2x. That's represented here. And we're going to show that they're not equal. Over here we also have 2x. And we're adding 6 to it. Now if we're adding 6 to it, right, shouldn't it be balanced if we just have this with this? It would be balanced if we have that. So the fact that we're adding 6 to this side of the equation means that this side should be going down, this side should be going up. It would be unbalanced. So let's look at question 10. If a bag is removed from both sides of the balance, the equation is x equals x plus 6. So in other words, if we take that bag away and we take that bag away, see, we're left with x on this side and x plus 6 on this side. So is that a contradiction? Well, let's say you're confused. Let's substitute a value in for x, right? So let's write what we have here. We have on this side, we have x. I'm going to write it over here. On this side, we have x plus 6. Now, if we substitute in a value, by the way, we're saying that this is probably not going to be equal, but let's substitute in a value. If we substitute in a 3 here and a 3 here and add 6 to it, do you see that 3 plus 6 would be 9? And there's no way that 9 would ever be equal to 3. They're not equal to each other. So it's a contradiction. So what are we picking? We're not picking this because they're not balanced. The two things, this is a heavier side than this side. So that leaves us with choosing that last choice.